Julie, you want to come up and tell us about Roman? Roman update. Okay. So you can hold this one.
Thank you. So this is the whole meeting about Roman, so I'm kind of assuming that everybody knows what Roman is.
Okay. All right, and then this should work if you want to use that.
One of the things that I find remarkable with the Roman project is how much work, even things that you think might be relatively simple, like how do you take the observatory from one place to another place. So we made a video. So this is the purge filtered air and part that is in the air conditions using the going now. That gets and we move up and down. 10 minutes after leaving the gate, we had a huge thunderstorm. And it moves at walking pace. And at about dawn, we arrived at the port with one of the few roll-on, roll-off docks. This is now on the Pegasus barge, being tugged by the Crosby Trojan, the Bay Bridge. Now arriving in the boat. So we're there. So this is a picture of Roman in its new clean room. There is a clean room high bay on in this building, and then immediately adjacent to it is what we call the airlock, which is a kind of clean building, and SpaceX are starting to work on their half of the work in the airlock today, while we're preparing Roman on the clean room on the other side. And when both sides are ready, we'll open the door between and merge the two together. We've built this observatory without making compromises. Every performance measurement meets or exceeds requirements. We've completed our last pre-launch life cycle review. So a life cycle, a NASA mission has a bunch of phases, A, B, C, D. E is operations, so it starts after the end of commissioning. We don't want to talk about F, that's end of life. So we've had the last life cycle review that we want to have. And we will have key decision point E, which is the meeting at headquarters to formally get approval to continue into phase E in mid-August. We remain on track for a launch readiness date of August 30th. That is 9 months ahead of our launch commitment to Congress. It's 2 months ahead of our launch commitment that we had pre-COVID, so we caught up on all the time that we lost during COVID, where we had an extensive period of paying people to not be able to do the work and then having to pay them later to do the actual work again. So the next step is launch. There's a reasonable amount of work and reviews between now and then, but basically we're at the finish line. So this is very exciting, very real, and what we have now on the observatory, and to some extent what we have now on the ground system and the pipelines, is what we're going to be using to figure out what way is up after launch. I'll give my standard, Roman is great because we have a large field of view, but it's also because we can survey large regions of the sky effectively. Both of those contribute to Roman having an excellent ability for surveys. But that tells only half the story. Roman isn't only great for doing surveys. Lots of missions have wide field of view. Roman is great because we do large surveys with exquisite sensitivity and outstanding calibration and performance knowledge. The core of our observing program is our core community surveys. These are 3 large, ambitious surveys that are designed to address the science questions and the mission objectives that were handed to us by the 2010 Decadal Survey, which itself covers everything because it's astrophysics, cosmology, and exoplanet demographics. We have chosen to define each of these surveys not by picking a team to be the survey team, but to conduct a community process where the goal is to collect the data that we need to address our cosmology and exoplanet demographics objectives, but to otherwise design the survey to maximize the science return across a broad range of science areas. And that's how, for example, we've ended up optimizing the cadence of how we collect the deep field in our high latitude wide area survey to be optimized to find outer solar system objects. And I think we may not naturally have found that synergy had we not used a open community process to define the surveys. This is what the surveys look like on the sky. As Lee mentioned, these are a revamp from the design reference mission that we had been working to in the design phase of the mission. And what's important and different here is that we've considered a much broader range of science cases. We've taken into account that other observatories exist. It is not an accident that almost all of our large surveys are biased to have overlap with Rubin. Roman and Rubin were prioritized in the same decadal survey. They are designed to be synergistic. That works best if you make your observations such that the synergies can be allowed to happen. Again, I'm not going to any of this in too much detail because I'm assuming you all already know much of this. Lee also mentioned that we have announced the selection of our first general investigator program. This provides the resources needed for the community to conduct investigations over an incredibly broad range of science using data from our existing surveys, which represent more than 75% of the time of the mission, and opportunities to select additional surveys. And these additional surveys have range from a deep field, covering Kepler fields, looking at nearby galaxies, so add real breadth to our capabilities. If you didn't apply to Cycle 1, or you applied and you were not successful, or you applied and you want more money, please keep an eye out for Cycle 2 that we expect to release at Q4 2026 with a deadline in Q1 2027. This will be the first Roman proposal call where you will have had an opportunity to look at real flight data prior to writing your proposal. So what happens after launch? Well, we spend the first, this is not at all to scale, so most of this bar chart is 90 days, and then the 5 years of the mission is that little thing in blue. But we spend 90 days commissioning, and that's where we do calibration, we characterize our point spread function, we calculate survey efficiency, we get a first set of all of our calibrations. At the end of commissioning, we think we're going to have a pretty well-calibrated observatory. It is not going to be perfect. Some Roman calibrations simply take more data, collection of more data to get good. One way to think of this is as characterized by Jeff Crook, that we think it will be pretty straightforward to get Roman calibration to about the level of Hubble calibration. So that's something that took Hubble, many years. The challenge with Roman is to get to the more stringent calibration requirements that we have on Roman. So when we talk about the beginning of the mission not being perfect, it's pretty good. It's pretty science ready. Right out the gate, at the start of science operations, we will make all of our commissioning data immediately public. That is going to include observations of our spectroscopic and astrometric and photometric calibration fields. So those will also be very good fields for exploring spectroscopy, photometry, and astrometry with Roman. And there are some interesting time domain observations during commissioning too that may be of interest. Prompt data products will be immediately start flowing public, and for Roman, that is a full suite of products. So calibrated pixel data, coads, mosaics, to single band catalogs. We've divided baseline science operations into early and nominal. And that's not really that we're doing anything different between early and nominal. We're just recognizing that in the very early part of the mission, our calibrations are still going to be fairly rapidly improving. So our commitment to you is that we will be communicating more frequently to the community on the evolution of our performance, our calibrations, our pipelines during this period. So we could take a quick look at a sketch of our first 2 years, and this is extremely simplistic. Our Science Operations Center have put together a detailed mission plan. We will have 3 seasons of the Galactic Bulge Time Domain Survey in the 72 days, twice a year that it is visible. We are prioritizing coronagraph observations before the first GBTDS season, and that's because that instrument has a 18-month prime mission, and they need to get the data early so that they can make the case for extended operations with CGI. We'll conduct a high-latitude time domain pilot survey in the first 9 months or so of the mission. That will allow us to create a reference image. It'll give us early measurements of supernovae and variable objects there. And we will focus on the deep fields in the high latitude wide area survey, because that is what is needed to understand the performance of the observatory and get us on the right path to knowing if we're executing the correct surveys over the rest of the mission. So what can you expect? If all is well at the end of commissioning, and I want to, just a small caveat, every single time we have turned on the focal plane with Roman, we've had a horrifying discovery. So when we were doing thermal vac testing with just the focal plane itself, we found an increase in dark noise that led us to replace some of the detectors. When we were testing the instrument, we discovered that there was significant thermal stray light that led us to design and install an additional set of baffles. And when we were testing at the entire observatory level, we discovered that one of the detectors wasn't reading out, and we were seeing evidence of ice buildup on the surface of the detector. So we haven't arrived on time and on schedule because we didn't have problems. Roman is on time and on schedule because we know how to solve them. So I'm confident that we are going to find things we didn't expect during commissioning, but I'm equally confident that we have experience with working together to solve those issues. So there's a reasonable chance that at the start of science operations we actually will be nominal. And in that case, the SOC is going to be producing prompt products all the way from level 2 to level 4, so calibrated pixel data all the way through to single band catalogs. The first delivery from The MSOS pipeline, which is the pipeline that processes data from the Galactic Bulge Time Domain Survey data, will be delivered around 4 months into the mission, because that's driven by when those observations are taken. The first delivery of spectroscopic data is going to be about 6 months into science operations. Again, this is driven by when those data are collected. The RAPID team are planning to spend the first 4 to 6 months of science operations in a beta testing mode to validate their transient detection and classification, after which they'll go into full production mode. So in the early phase, they'll be available to anybody who wants to participate on an at-risk basis, but we're really standing behind them after the 6-month mark. But I do want to caution that even in the nominal case, it's likely that there is going to be significant evolution in the quality and breadth of available Roman data in the first 6 months, which is why we're calling the first 6 months early science operations, and beyond that, nominal science operations. So, you could ask the question, are we ready? And to some extent, you never feel ready. But we are ready. We have defined what observations we want to take. We've had a community process for both the wide field and the chronograph observations to define the bulk of the Roman observing program. And that has produced an outstanding set of surveys. We've selected additional surveys through the Cycle 1 program. We've merged these into a cohesive mission plan that includes the impact of needed calibrations on that mission plan. We've completed a calibration plan. We've implemented and tested our pipelines. We've frozen the code. The pipeline details have been extensively discussed in the calibration and software groups, and if you don't know what those are, you should join, because this is the place where you, the general community, can talk with the mission team about what is in our calibration plan, what is in our pipelines, and influence things as needed, or from our perspectives, help us make it better. And then finally, the analysis environment, the Roman Research Nexus, has been released and publicly available since last December, so we're ready to go. So we're all here to join in Roman, and soon we'll be wallowing in data. Thank you.